There is a rectangular brick wall in front of you with n rows of bricks. The ith row has some number of bricks, each of the same height, but they can be of different widths. The total width of each row is the same. Draw a vertical line from the top to the bottom and cross the least bricks. If your line goes through the edge of a brick, then the brick is not considered as crossed. You cannot draw a line just along one of the two vertical edges of the wall, in which case the line will obviously cross no bricks. Given the 2D array wall that contains the information about the wall, return the minimum number of crossed bricks after drawing such a vertical line. In the first example below, we're given a wall with 6 rows where the total width of each row is 6. The output is 2 because 2 is the smallest number of bricks crossed by a vertical line within the wall. Drawing a vertical line at this position along the wall crosses only 2 bricks. There isn't another vertical line that can be drawn that crosses fewer than 2 bricks. In the second example below, we're given a wall with 3 rows, where each row contains 1 brick having a width of 1. The output is 3 in this case. This is because any vertical line drawn within the wall crosses 3 bricks. Okay, going back to the wall in the first example, just by visually looking at the wall, how could we find that the minimum number of bricks crossed by a vertical line is 2? There are many possible vertical lines that we can draw, but most of them actually cross a brick in every single row. And our goal is to minimize the number of bricks crossed, so what we should do is only consider vertical lines that cross edges. There are 5 vertical lines that cross edges in the wall. Each vertical line is located at a different position along the wall, so I'll be referring to their positions based on their distances from the left side of the wall. So the line at position 1 crosses 3 bricks, the line at position 2 crosses 5 bricks, the line at position 3 crosses 3 bricks, the line at position 4 crosses 2 bricks, and the line at position 5 crosses 4 bricks. And we know that all other vertical lines drawn within the wall cross 6 bricks. So then we can conclude that the minimum number of bricks crossed is 2. Now I want to highlight a useful property that each vertical line drawn has. For any vertical line, the number of bricks crossed plus the number of edges crossed equals the total number of rows, which is 6 in this case. Our goal is to find the number of bricks crossed for each line that crosses an edge. An indirect way to get the number of bricks crossed by a line is to find out the number of edges it crosses. For example, the line at position 1 crosses 3 edges. With only 6 rows in total, we know that the line must have also crossed 3 bricks. So we can reform our problem into finding the number of edges crossed for vertical lines that cross edges. So how can we do this given the 2D input array wall? Imagine that we are building this wall ourselves, row by row and brick by brick. And as we build the wall, we want to keep track of the number of edges occurring at various positions along the wall. So we're given the first row of bricks, and there are 4 bricks of size 1, 2, 2, and 1. The information we want to find out in each row is where all the edges in that row are. An interesting insight here is that the number of edges in a row is 1 less than the number of bricks in that row. So if I have 4 bricks in a row, there must be 3 edges that connect those 4 bricks. Edges are located between any 2 adjacent bricks. So let's say we're laying down the bricks in a row, one by one. Every time we place a brick down, we know that there will be an edge immediately after it because the next brick we place down is going to go right next to it. Now the only situation where this isn't true is if we're placing down the last brick in the row. So this tells us when we will encounter edges, but we also need to know exactly where they are located along the wall. The exact position of an edge is the sum of the bricks to the left of it. So as the bricks are placed down, we'll keep track of our position along the wall by keeping track of the total width of brick placed so far. To see how this works, let's rebuild this row from the beginning. At first, our position is 0. Then we lay down the first brick in the row. It has a width of 1, therefore our new position is at 1. And since this brick isn't the last brick in the row, we know there is an edge at this position. So we make a note that so far we found 1 edge at position 1. Then we lay down the next brick, and its width is 2. So we update our position by adding 2 to it, which means we're now at position 3. Again, this isn't the last brick in the row, so there's an edge at position 3. Then we lay down another brick having a width of 2. So we add 2 to our position, and now we're at position 5. This brick also isn't the last brick in the row, so there's an edge at position 5. Finally, we lay down the last brick in the row. Note that we don't need to update our position for the last brick, since we're only keeping track of our position to locate where all the edges in a row are. But I'm going to update it anyway, and our new position is at 6, which is at the right side of the wall, and we're not allowed to draw a vertical line here. And this happens each time we lay down the last brick in any row. Now we can move on to laying down the second row of bricks. This row has 3 bricks of size 3, 1, and 2. Since we're building a new row, we reset our position back to 0. After placing the first brick, our new position is at 3. So we increment the number of edges found at position 3 by 1. Then we lay down the next brick, and its width is 1. So our new position is at position 4. And since this isn't the last brick, there's an edge at position 4. Finally, we lay down the last brick in the row. Now after building the first 2 rows, we found that there is 1 edge at position 1, 2 edges at position 3, 1 edge at position 4, and 1 edge at position 5. After repeating this process for every row in the wall, we would find that there are 3 edges at position 1, 1 edge at position 2, 3 edges at position 3, 4 edges at position 4, and 2 edges at position 5. Now we have all the information we need to find the minimum number of bricks crossed. The line that crosses the minimum number of bricks must also be the line that crosses the maximum number of edges. So the minimum number of bricks crossed plus the maximum number of edges crossed equals the total number of rows in the wall. Therefore, the minimum number of bricks crossed is the total number of rows minus the maximum number of edges crossed. And we found that the maximum number of edges crossed is 4, and we know that the total number of rows is 6. So the minimum number of bricks crossed is 6 minus 4, which evaluates to 2. Finally, let's implement this solution in Python. First, I'll import the default ticked from collections. Then we define the function leastBricks that takes in a 2D array wall. Here, we set the variable edges to be a default ticked where the default value is 0. Edges is a dictionary that we will use to keep track of the number of edges at various positions along the wall. So the keys in this dictionary will be positions, and their values will be the number of edges found at that position. Next, we loop through each row in the wall. For every row in the wall, we first set our position to be 0. Then, for every brick in the row except for the last brick, we update our position by adding the brick width to it. Then we increment the number of edges found at that position by 1. After we finish doing this for each row in the wall, we finally get the minimum number of bricks crossed by returning the number of rows in the wall minus the maximum number of edges crossed. To get the maximum number of edges crossed, we take the max of the values in the edges dictionary. The default equals 0 argument is included for the case where no edges exist within the wall.